Come on. I was doing this yesterday. Let's open a jam. Okay, so today we're going to do a Nearpod, and then remember yesterday we started learning about corresponding parts of congruent triangles are congruent, that long word, but then we abbreviated it CPC-TC for triangles, and then it had an F for figures, so we did CPC-FC for figures. And so if I just talk about triangles for now, remember that meant there was going to be 6 parts that were congruent, right? So 3 angles on one triangle were congruent to the other 3 angles on the other triangle, right? So 3 pairs. And then 3 sides were congruent on one triangle to the other triangle, right? So it was 3 sides and 3 angles. So there were 6 parts to it, okay? So today we're going to learn a couple postulates that tell us that we don't necessarily need all 6 pieces to determine that triangles are congruent. We could actually have less. Okay, so that's what we're learning today. We're just going to learn 2 of them. There will be 4 total. We're learning the other 2 on Thursday. So we're just going to learn 2 of them today. Okay, so I think everybody's on, so I'm going to get started on it. Okay, so this just refreshes our memory about what congruent means. So remember, it's going to be 2 geometric figures that are exactly the same size, same shape. And so I could put the one figure on top of the other and all the vertices lined up, remember? And so we said we might have to maneuver that a little bit. Maybe we have to flip it or turn it or slide it to make sure it lands up correctly. And so in this picture, we have polygons. And so we'll see that we color coordinated them. So like A is red, and that came first in naming it. Well, what came first in naming the other one? E, right? And so since those are both red, we know that this figure on the right would have to be kind of like flipped over in order to line up the vertices that are corresponding, the ones that match, right? And so yesterday we practiced writing out these statements. And so we said side AB would be congruent to EF. And we said that order matters, right? So we were big yesterday about practicing the order. Okay. And so we're still going to be practicing that also. So I wanted to kind of refresh that from yesterday. So also yesterday we said, okay, in a triangle, we have 6 pairs of corresponding parts, 3 pairs of sides and 3 pairs of angles. And we listed them all out yesterday, right? And so we got this nice list right here where it said, you know, the purple corresponds with the reds and everything lines up nice. And so since it had these 6 pieces, we could then say that triangle ABC was congruent to triangle DEF. Okay, so the whole point of these is if it has corresponding parts, then we know that they're in fact congruent. But it also works the other way around. If I tell you they're congruent, then you know it has corresponding parts. So really this arrow could be going both ways because you could show both ways, okay? So the question is, do I need all 6 parts to determine if a triangle actually is congruent to another triangle? And the answer is no. I can have 4 other postulates right here that we're going to learn. These are the abbreviations. We're just going to focus on the first 2 today. And I can have those, and that would mean that they're congruent. Okay? So your first activity, make sure you're paying attention, is do I need all 6 pieces to determine a triangle is congruent? You can just circle it. There's like a little thing on the bottom. There should be like a little pencil on the bottom that you can just circle yes or no. Or check. I see some of you did a check mark. So the answer was no. We don't need all 6. Okay? So the first postulate that we're going to learn about is called side, side, side. Or for short, we just say SSS. Okay? So this postulate says if I have 3 sides of one triangle that are going to be congruent to 3 sides of the other triangle, then I know the triangles themselves will be congruent. So I can determine just from SSS, and I don't even have to know the angles. Okay? And that's because if the sides are congruent, they're going to create the same triangle, right? So if I have this red side congruent to this red side, and the blue side congruent to this blue side, and then the purple and the purple, they are going to be congruent triangles because those sides, when I match them together, if they're the same length, they're going to create the same angles, okay? And so I don't even need to know the angles. So this postulate says if you see side, 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 like if you see that happening, you can determine then that the triangles are congruent. Does that make sense? And it's because they are going to create the same angles. And so you're actually proving that the triangles are congruent without all 6 pieces. You just needed 3 sides. Okay? So another way to look at it a little closer is I have no information given about angles in this, right? So my question is, are all 3 sides congruent to all 3 sides of the other one? And so we're comparing the blue triangle to the red triangle, right? And so since AB is congruent to DE, that's one side. BC is congruent to EF, that's a second side. And then AC is congruent to DF, that's a third side. Since I have 3 sides that are congruent, I can say for sure, because of this postulate, that these triangles are congruent. Okay? Any questions on that one? Okay. So here's a question that comes up quite a bit. So my question to you is this an example, this picture, is it an example of SSS? So like if you saw this on a test and I said, hey, are these congruent because of SSS? What would you think? Yes. So I'm hearing yes. So my question is why? They have 3 sides that are congruent to 3 sides. So let's look at it. We have JK is congruent to NK because those both have 1 tally mark. So that's one side. And then we have JA is congruent to NA that has 2 tally marks. So that's 2 sides. And then we have AK and then AK. So what's going on with AK? Good. The 2 triangles are sharing that side. And so my question to you is, does AK equal AK? Yeah, they're the same. So of course they equal. So remember that identity property we learned a while back? So this is part of that. So it equals itself. So I know that AK equals AK because it's the same line. So yes, this is SSS because that side is congruent to itself, right? And so good. This is an example of SSS. So then I know that these 2 triangles are in fact congruent because SSS works. Okay, and so that's what you're going to start when we're doing problems today. It'll ask you, are these triangles congruent and why? Like which rule? Okay, and we're only learning 2 today. So before I tell you the other rule, I want you to learn what an included angle is. So an included angle is the angle that's between 2 sides that I'm talking about. And so for example, in this first one, I have GI, I have this side with 1 tally mark. And then the other side that has a tally mark is GH. In between those 2 sides, I have an angle. That angle that's in between is called an included angle. Okay. And so then I show you two other examples. So in this case, if I'm talking about GI and HI, the included angle would be I because it's in between those two. Okay. And this is going to be important for our next rule to know which angle is in between the sides. Okay. So again, for this one, H would be in between these two sides. That's called an included angle. Included in between the two. So these are three different examples showing where the included angle is. Okay. All right, that's important because our next rule is side, angle, side, and it has to follow that pattern. The S has to come first, the side, then the angle's in the middle of another side. So that's why this included angle is important. So if I have two sides and an included angle on one triangle that are congruent to two sides and the included angle of the other triangle, then I can actually say that these triangles are congruent because of the rule SAS. Okay? So what does that look like? It looks like this. So if side AB is congruent to side DE, that's one side. And then I have side AC is congruent to side DF. That's a second side. And then the angle in between those sides is angle A and angle D, and those are congruent. So if I have a side congruent to a side, the angle, and then another side, then they are congruent triangles because of side, angle, side. They have to follow that pattern though. Okay. So let's look at a little closer example. Okay. So this one says, okay, number one, I have one side, AB is congruent to DE. Then I have an angle. Angle A is congruent to angle D. And then I have another side, AC is congruent to DF. Does it include the angle in the middle? Side, angle, side. Yes on the purple. How about the red? Side, angle, side. They match. We're good. That means triangle ABC is congruent to triangle DEF because of side, angle, side. Or if we want to abbreviate SAS. Okay. The sassy angle. Does everyone understand what the included angle means? Okay. So I want you guys to try now. So we're going to try a couple problems. And you're going to identify, are they congruent? And if so, are they congruent because of SSS or SAS? So you only have three options here. They're either not congruent, they are congruent because of SSS, or they are congruent because of SAS. Okay, that's all we're practicing right now. So go ahead and pick your little avatar guy. Lots of bears going on. There we go, we got a frog. One more. Who are we waiting on? One more avatar. Did we lose someone? Who didn't pick a little guy yet? Somebody didn't pick a little guy. I want you guys to practice these, so. There we go. Okay. All right, here we go. All right, so if you look at the picture, are the two triangles congruent? If so, how do you know? So they're either not congruent or they're side, 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 or side, angle, side. Gotta be true on both triangles. Okay, state if these two triangles are congruent, and if so, how do you know? Remember, it has to follow the patterns. Are these two triangles congruent? If so, how? Side, angle, side. It has to follow that pattern in both triangles. Okay, state if these two are congruent. Okay, question 5. Are these two triangles congruent? If so, how? Number 6, are these two triangles congruent? If so, how? Number 7, are these two triangles congruent? If so, how? Number 8, are these two triangles congruent? Are these two triangles congruent? Are these two triangles congruent? If so, how? Okay, the next 3 have different instructions. They're going to tell you how they want them to be congruent. What do you need in order for it to be like that? So, I want it to be SAS. What additional information do I need? It stopped? Or for all of you? Okay. We'll do number 11 together in a little bit then. Still stuck? All right, so we want side, angle, side. We have this side, we have this side. Vertical angles are congruent. So the other sides I would need would be JI and EI in order to have side, angle, side. So the missing information is JI needs to equal EI. Okay. Let's hope number 12 and 13. Did it catch up? No? All right, so we want SAS here. What information do I need? Think about it for a minute. So I have side LM equals HG. I have LK equals HI, so I'm missing the angle. Which angles have to be equal? Go ahead, anybody. To have side, angle, side, what 2 angles would need to be equal? L and H, good. All right, last question. I want SSS. They have a tally mark on X, Y, and CD. They share ZX, so those are the same. So you need to have one more side congruent to each other. So what sides need to be congruent to each other? So I have one side here, one side here. They share a side, so we know that one's equal. So I would need DX to equal YZ. If those equaled each other, we'd have SSS, okay? Okay, so were there any that stumped you? Like at the beginning, any of the ones that weren't congruent? So like number 4, let's look at 4 just real quick. So number 4, you should have chose not congruent. Now, if you only looked at the first triangle, it does have side, angle, side. That first triangle, we're like, okay, that looks good. But then we have a problem. This angle is not in between the two sides, right? And just so you know, in geometry, we don't spell bad words. So A, angle, side, side is not a postulate, okay? Just so you know. No bad words in geometry. So this does not work, okay? These ones did work because they share a side and we're good. Let's go to the other one that didn't work because those tend to be the hard ones. So this one, they share a side on number 9. So we have side, angle, side. So this top one works, but then we have an issue. We have side, but then our angle's over here. So we would need the side to be here. Or we would need side, angle, side, right? So that's why 9 was not congruent because they both didn't follow the pattern. Are there any questions there about how these two work? Okay.